Hello everyone. In this video, we are going to cover the assignments for week number 3 of the course. So if you pull up the course schedule, you see that we are here in week number 3. We went over Jupyter Notebook, Markdown cells, and how to enter math mode using LaTeX and Markdown, and some basic plotting with Matplotlib that we can do inline in our Jupyter Notebooks. Now, the reading for this week is in the optional textbook Python for Data Analysis by Wes McKinney. This book is not required, but I highly recommend getting your hands on a copy and reading through these chapters. We'll also be referencing some chapters next week when we talk about some of the numerical libraries and data analysis libraries available in Python, NumPy, SciPy, and Pandas. Now, the micro assignment this week, MA2, is going to have you get your feet wet writing your own Jupyter Notebook. So let's take a look at MA2. So learner objectives for MA2 include writing Markdown and code cells in Jupyter Notebook, typesetting equations using LaTeX, and creating basic plots with Matplotlib. So for this assignment, you're going to derive a loan payment schedule numerically and graphically in Jupyter Notebook. And no worries if you don't know very much about loan payment schedules. Everything you need to know is listed here in this document. So read a little bit about amortized loans and the monthly payment calculation. I provide the formula here. So your monthly payment is based on a monthly interest rate. P is your principal. Say you're going to buy a car, so P would be the principal cost of the car, and N would be the number of monthly payments. So say you're going to take out a loan to buy a car. Your loan is for 5 years. 5 times 12 is 60, so you would have N monthly payments. And your monthly interest rate could be based on a yearly interest rate that you would need to convert from a percentage to a decimal by dividing by 100, and then converting that annual interest rate to a monthly interest rate by dividing by 12. So for example, say you're getting a 2.5% yearly interest rate, we would divide that by 100 and then again by 12 to get your monthly interest rate, which is needed for the monthly payment formula calculation here. You can compute your remaining loan balance using the following formula. Moving on to program details. So you're going to make a new Jupyter Notebook. So you'll launch Jupyter Notebook locally on your machine, open a new Jupyter Notebook and start from scratch. And you're going to include the following items in Markdown and in code cells. So include a description in your own words of amortized loans, relevant formulas using LaTeX. Now I know you can come up here and copy the LaTeX that I use to generate these in Jupyter Notebook, but really try to write them yourself using what you see here and your knowledge of LaTeX. And then you're going to write code to prompt the user for what the loan is for, perhaps a car, a principal loan amount, yearly interest rate of the loan as a percent, and the number of years of the loan. So write code to display the monthly payment, the total amount paid in interest, and the total amount paid for the loan. Write code to display the loan repayment schedule. If you need some hints about how to do that, take a look at this link here. And then write an inline MATLAB plot that looks like the following graph here that I pulled from this website. So a real loan calculator website. And here are the requirements to include in your graph. So this may seem like a lot. You may not be familiar with some of the financial calculations going on here. That's why I provide an example. So suppose the example is for a BMW i8, a very expensive sports car. We can run through the program using this example. And you can always check your work with online mortgage calculators or payment calculators. And in fact, BMW on its website has a payment calculator that you can enter in your same numbers and compare to make sure that yours is in fact correct. So essentially we're writing some of that back-end functionality for sites like BMW. Okay, so here's the interaction. What is this loan for? BMW i8, please enter the principal amount for the loan. Here's the cost of the car, about $142,000. Please enter the yearly interest rate as a percent. Say you're getting a percentage rate 2.0%, and please enter the number of years for the loan. So that would be 5 years, 60 monthly payments. So here's the output. Your average monthly payment would be about $4,158. The total amount you would pay in the loan would be $250,000. If you subtract out the cost of the car, the amount of interest paid is $107,000 in 5 years, which is quite a bit. Okay, so moving on to the loan repayment schedule. So this is going to show the first couple months what your starting balance is, how much you are going to pay in principal and in interest. These columns are not quite lined up in Jupyter Notebook, but that's okay. They're still in the same order. And then the last month's payment, okay, this is one-based indexing, and then make sure your math works out such that your 61st month or the first month after the number of years times 12, everything is a zero balance. And you should be creating a plot that looks somewhat similar to this using Matplotlib. So this is my rendering of this payment schedule graph on this website. Yours doesn't have to be the same colors and whatnot, but it still needs to include the same information that is listed here. And one thing to note is all values should be rounded to 2 decimal places and displayed with a $sign if you're referring to money. Some bonus here is to add some more bells and whistles to your plot, such that making the units for the x-axis be years and adding a $sign to the tick labels. So that is not by default with Matplotlib. Okay, usual grading guidelines and submitting assignments. Go ahead and get started as soon as you can.